Section 5.3, interpreting rate of change and slope. In this section, we're going to figure out everything there is to know about slope. And it comes down to one really simple thing, essentially, which is just a bunch of subtraction of some numbers. So rate of change and slope are the same thing. Okay, so rate of change and slope are defined as the change in y over the change in x, or the change in y relative to the change in x. So if you look at this first example, right, you have this table. You have your x values up on top and your y values up on bottom, like you normally do in a table. And rate of change is the change in the y values relative to the change in x values. So in this problem, we see for the first couple years, the change in y values is 0. And the change in x values from year 3 to year 4, that's a change of 1 year. So this rate of change, 0 over 1, is 0, indicating to us that over the course of year 3 to year 4, there was a 0-cent increase, or essentially 0 cents per year. Now that one doesn't really strike us as, anything useful. So let's get on to the next part of this. Let's look at the next two set of numbers. Let's look at this one and this one. So when we jump from here to here, that's an increase of 2 cents. So that change in y is 2 cents. But it increased those 2 cents over the course of 2 years. Right? From 4 to 6 was 2 years. So the change in y was 2 because we went up from 37 to 39, 2 cents. And the change in x was 2 because it went from 4 to 6, change of 2 years. So its rate of change is 2 over 2, which simplifies to simply just 1. Right? Indicating to us that this rate of change is an increase of 1 cent per year. Right? Basically, if you have year 1 and year 2, I'm going to say year 1, year 2, and you have 2 pennies, right? You increase 2 pennies over the course of 2 years. Essentially, the first penny is from the first year and the second penny is from the second year. That's how those 2 pennies can get split, right? If you gained 2 pennies over the course of 2 years, then it was evenly distributed as 1 penny for the first year and then the second penny the second year, right? 1 penny per year. Let's look at another one, right? Let's look at the next combination of numbers from 6 to 8. So from year 6 to year 8, the increase in pennies was 39 to 42, which is an increase of 3 pennies. So the change in y is 3. And from 6 to 8, that's a course of 2 years. So 3 pennies over the course of 2 years, which this simplifies 3 halves to 1.5 cents per year. Now, yeah, I know you're probably thinking, like, what do you mean half a cent? There's no such thing as half a cent. No, not really, but it's kind of an average, okay? It's kind of like an average. So we're not trying to find the exact, there's not like necessarily an exact number, it's just an average. So think of it like this, right? You've got 2 years, right? Year 6 to year 8. So 2 years go by. So again, we'll say year 1 and year 2. And there are 3 pennies that you gained over the course of those years. Well, if you split them evenly, that would be a penny and a half on year 1 and a penny and a half on year 2, right? 1.5 cents per year. But we already knew that because 3 over 2, 3 pennies over the course of 2 years is simplified to 1.5. And then our last one, right? We increase 4 cents from 42 to 46, so an increase of 4 cents. Remember, the change in y comes first. Over the course of 5 years, year 8 to year 13 is the course of 5 years. And of course, this simplifies to 0.8. So in this case, 0.8 cents per year. And if you want to see a visual of this, then you can think, okay, let's see, year 1, year 2, year 3, year 4, year 5, right? There are 5 years, right? But only 4 pennies gained over the course of those 5 years. So it's not even 1 penny per year, because if it was 1 penny per year, right, we don't have a 5th penny to go for the 5th year, right? So it's less than a single penny per year, right? In this case, we can tell it's less than 1 cent per year because it actually ends up being 0.8. So think of it like this. Take 0.8 of this penny, right? And it goes to year 1. Take 0.8 of the next one. So imagine, so this was like 0.2 of this one. So we'll take, 0.2 of this one and then 0.6 of this one. That makes a 0.8, right? That would be year 2. And then this would be a 0.4 left of this one. And we would take a 0.4 of this one. If that makes any sense, right? That's another 0.8 if you combine them. That's year 3. I forgot my 4th penny. There it is. So let's take a 0.6 of this one and a 0.2 of this one. That's a 0.8. That goes this one. And then the last part, you can see if that'd be 0.8 of the last penny going there. So essentially, you can sort of divide the pennies up in that sense. Yeah, obviously, I know you can't really have 0.8 of a penny, but that's kind of the gist of it. How can you break up 4 pennies evenly over the course of 5 years? That's the only way you can do it, if you could cut pennies into pieces of 0.8. You know what I mean? Now, if I confused you, if I lost you, I apologize. We're going to get to part where, things really start to come together. But this is essentially what rate of change is, right? It's a change in y relative to the change in x. So this is a quick summary of the points we made earlier. We've already established all these numbers up here on the right-hand side of your screen, but we're going to fill it in here. So this was 37 minus 37, which we mentioned was 0 cents per year. We've already established that back up there. So all these are the same thing, right? Year 6 and year 4, that was 39 minus 37, which was 2 cents over the course of 2 years, which we already came to the conclusion that was 1 cent per year. We had 42 cents minus 39 cents. That was an increase of 3 cents over the course of 2 years, which again we've established was 1.5 cents per year. And then the last one was 46 cents minus 42 cents over the course of 5 years. So it was 4 pennies over the course of 5 years, which was 0.8 cents per year. So this is all just the same thing that we've already established from earlier, but it was just filling in those boxes. Now, if we graph this, okay, I'm going to have to graph this really, really carefully. So we're just graphing the table that was given to us. Where is that table? If it loads there, that table there. I'm just graphing these points from that table onto this graph. So 337, 437, 639, 842, and then 1346. And then we connect these with a line. Let's try to make this, let's do it in red. Let's make it very thin. Okay, so there's that one. Try again. There's this one. There's this one. And there's this one. Okay. Now, rate of change is the same thing as slope, as I mentioned. So there's a connection between the rate of change and the steepness of our line. Remember, the rate of change for these 2 years was 0. The rate of change for these 2 years was 1. Between these 2 years was 1.5. And between these 2 years was 0.8. Right? These are all the slopes of those lines. And if you look very carefully, we're going to answer this in a question down later. If you look very carefully, it's kind of tough to tell. But the steepest portion of this line, the steepest portion is this portion here. The portion of the 1.5. You can kind of barely tell, but it is a little bit steeper than the other parts around it. And there's a reason for that. The reason its slope is the steepest, and when I say steep, I'm talking about the most vertical. Like for imagine, you had 2 lines. You had a line that's kind of like this and a line that's kind of like this. This one is much steeper because it goes up at a sharper angle, right? Think of it like a hill. This is a not very steep hill because it would be very easy to walk up, but this would be a very steep hill because it would be super challenging to walk up, right? So that's what I mean by steepness, right? Essentially the more vertical it is. And this part is the most vertical. And the higher your rate of change, the more vertical your line's going to be. So there is that connection. All right, we'll cover rise and run at a later time. So if we come back, we'll come back. But let's answer these questions, right? Between which 2 years was the rate of change the greatest? Well, remember, the rate of change was the greatest at the 1.5 cents per year. That's the biggest rate of change. So these are all the rate of change, right? The biggest one is 1.5. That was between 2006 to 2008, right? Year 6 to year 8. So between 2006 to 2008. Let me increase to that one level higher. There we go. All right, that was the greatest because its rate of change was 1.5, which was the biggest rate of change for that table. Compare the line segment between 2006 2008 with the line segment between 2008 and 2013, which is steeper. So we've already mentioned this, but the line segment from 2006 to 2008 is steeper. Okay, meaning it has a greater rate of change. Meaning it has a greater rate of change, also meaning a greater slope. So that's what we talked about earlier, right? Between 2006 and 2008, that's these 2 points on the graph, right? 2006 is this point, and 2008 is this point, right? And between those, that's where the line is the steepest. This is the largest increase or the biggest steepness of our graph between those 2 years. So that's what I'm saying in that second question. Now, how do you think the steepness of the line segment between 2 points related to the rate of change between 2 points is related to the rate of change it represents? So we've already mentioned that the steeper it is, right? Steeper equals larger rate of change. That's the main takeaway from this. So if I had a graph that looked like this, well, let's do it all increasing. Let's say it looked like this, 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 and this, right? Of these 4 line segments, the steepest line segment is this one because of how vertical it is. The most, it stands up the most, this one right here. So that would be the greatest rate of change. This line segment would be the largest rate of change, biggest slope. Okay, rate of change is just abbreviate. So that's essentially what we're trying to figure out, right? When we look at the graphs, the biggest rate of change is the bigger the slope. So now we're going to talk about rise and run, right? You've heard of rise over run before. Now, in the context of a graph, right, rise refers to the change in y because rise is how far up or down we go. So when you think about rise, right, think about the difference in y values, the change in y values. And then run, remember, run is the left or right motion of it, right? So how far over it goes. And that would be the difference in x values. So when you think run, think change in x, right? Difference in x. Now, the important thing to remember here is the y values are on the top part of this fraction. The x values are on the bottom. We're always going to mention that. That's one common mistake that people will do is they'll put the x values on top instead of the y values on top. So please make sure you made that distinction. All right. So the slope of this line, if we're counting rise over run, if you count rise over run, notice we start with the y values, right? We're looking at the y-axis and how far up this graph goes. Now, this graph starts at 1 because this point here is at 1, right? And this graph goes up to 4, right? So it goes from 1 to 4. So that's an increase of 3, right? So 1, 2, 3. That's an increase of 3 units. 1, 2, 3. You have to kind of remember that these are going by 2s here. So that's why I put these half marks because that's 1, 2, 3, 4. To sort of help us keep count. So it goes up 3, right? That's a rise of 3, up 3. So let's put that over here, right? Rise equals 3. Now, how far does it run, right? So it runs, remember, we're at 2 on the x-axis right now, and we run over just to 3, right? So if we're at 2 and we run over to 3, then we're running just one place, right? So our run is 1, making our slope, our slope is rise over run. So in this case, 3 is our rise, run is our 1, and that ends up being 3. Our slope would be 3. Now, mathematically, besides counting, we can actually do the math by just subtracting, right? So remember, slope, like I said, is equal to rise over run. But rise is the difference in y values, right? So difference of y, and run is the difference of x. And that's coming from, if you go back here, see how this thing takes forever to load. Rise is the difference in y, run is the difference in x. So just repeating that down here. So our difference in y, look at the y values. Remember these ordered pairs have an x, y, x, y. So the y values are 4 and 1. The difference would just be subtracting them, 4 minus 1. And the x values, the difference would be 3 and 2. So 3 minus 2. Difference means subtract. So you would just subtract the y values, 4 minus 1, which gets you 3, and subtract the x values, 3 minus 2, to get you 1. You get the same slope, right? 3 over 1, which is 3. So this is how we're going to do it with subtraction mostly, but you can count as well. It's just kind of hard to count on this graph because of the fact that each box goes by 2. Like, you have to kind of number it with these half marks, 1, 2, 3, 4. Because of the way the graph looks, it actually makes it kind of harder to count. So we're going to rely on just subtracting the numbers for the problems that we do. So in this case, again, let's rely on our subtraction. Here's your xy, xy. So slope, remember, equals rise over run. So our rise is going to be, remember, our difference in y, and our run is going to be our difference in x. So difference in y comes first. Difference in y goes on top. So our y values, we have 3 and 0. So we're subtracting these. 3 minus 0. 3 minus 0. That's going to be for our y values, which comes out to being 3. Now let's do the x values. Let's get the bottom part of this fraction. So the x values, let me use a different color. Our x values are -2 and 1. And we're going to subtract those. -2 minus 1, which ends up to be -3. So our slope is 3 over -3, which just simplifies to -1. Right? Because 3 goes into 3 one time. You have a positive divided by negative, so that number has to be negative. So a -1. And that's how we're going to find our slope. So we've already worked it out, but we'll go ahead and fill this in as well. So -2, 3 was the point in question. We did 3 minus 0, which was 3. We already know the answer. We had, on the bottom, we had -2 minus 1, which is -3, right? And our slope of the line was -1. So what is the rise of a horizontal line? So a horizontal line is a line that goes straight across, right? So what is its rise, right? Its rise, remember, is how far up or down it goes. Well, if it's horizontal line, right, then it doesn't really go up or down, right? So its rise is nothing, right? Flat line, so rise equals 0. So what is its slope, right? So remember, slope is equal to rise over run. So in this case, the rise is 0. Now we don't know what the run is because, it can be any kind of number, but essentially think of it like this. Slope would be rise over run. So pick any number. It could be 0 over 5 or 0 over 12 or anything like that. Because the 0 is guaranteed to be on top, because the rise of a flat line is 0, this will always come out to equal 0. So the slope of this line would always be 0. Now let's look at, for number 5, a vertical line. A vertical line is a straight up and down line. And this is asking what is the run of a vertical line. So basically the run is how far left or right this line goes. Well, if the line is going straight up and down, then it doesn't go left or right, correct? So in this case, the run is equal to 0 because it does not move left or right. It just goes straight up and straight down. Now, if we think about the slope of this, right? Remember, rise over run. We don't know what the rise is. The rise can be any kind of number. It might go up 5, 12, whatever. Right? But we know that the run is going to be 0 because it's a straight up and down line. It doesn't run to the left or to the right, so its run would be 0. Now, anytime you have a fraction like this, where you have a number divided by 0, it could be 5 divided by 0, 12 divided by 0, -3 divided by 0. Every time you do this, you end up with error, not 0. You end up with something that doesn't work. Okay? If you take a calculator right now, it can be your iPhone calculator, take any number and then divide 0. So 12 divided by 0, for example. Right? Your calculator will say error. And that's because the slope here is not 0, but the slope doesn't exist at all. So there's a difference between 0 slope and what we have here is an undefined slope. So undefined means the slope doesn't exist at all. 0 means the slope exists, but it's just 0. So there is a difference between 0 slope and no slope. That's the case here. So horizontal line has a slope of 0 because it's flat. A vertical line has a slope that's undefined, a slope that doesn't exist because it's going straight up and down. If you have a graph of a line, how can you determine whether the slope is positive, negative, 0, or undefined without using points on the line? So basically, I'm going to draw 4 graphs, right? Let's draw this one. Actually, let's use a different color so it stands out. Let's use red. This one, this one, this one, and this one. We could tell which one of these is which based off of just the angle of them. We can tell which one of these slopes is positive, which one's negative, which one's 0, and which one's undefined. Positive, negative, 0, and undefined. Just by looking at them. And here's how we can tell. Remember, when you read a line, when you read a sentence like number 6, if you have a graph of a line, you read from the left to the right. Correct? And that's how you need to read these lines. So ignore the arrows, just start from the left side of the line and work your way to the right. When you do that, left to right, you'll see that this line is increasing, right? It's going upwards, meaning that if it goes upwards, this is a positive slope. Okay, so it's very key that you read from left to right. Left to right. It's very important. So if we do that on the next one, from left to right, we're decreasing, we're going down. So this is a negative slope. Now these last two, there's no left or right really because we have already answered this question in numbers 4 and number 5. A vertical line that's straight up and down is undefined. And a horizontal line that is flat has a slope of 0. So there's no math intended there. You just always recognize a vertical line is undefined and a flat horizontal line is 0. So let's try a couple examples here of finding the slope. So this is going back to our subtraction, okay? So remember, slope equals rise over run. Now, rise is the difference in y. Run is the difference in x. So we're just going to be subtracting here, okay? So let's identify the y values first. Difference in y. Let's use a different color. No, we'll keep it as blue. It's fine. Difference in y. So our y values, here's x, y, x, y. So our y values are 3 and negative 3. So we're going to subtract them. It'll be 3 minus negative 3. Be very careful about your negative here. You can't say 3 minus 3 because then you're forgetting about the negative in this point. So you have to make sure that you have the minus sign and you include the negative from the 3. Okay, so be very mindful of that. Negatives can be tricky. And then for the x values, we'll subtract them from each other. So the x values are 5 and 0. So we're going to subtract them. 5 minus 0. So we end up with a slope. 3 minus negative 3 is 6, because essentially a minus negative becomes a plus. So think of this as like a 3 plus 3, which is 6. And then 5 minus 0 is 5, right? 5 minus 0 is 5. So our slope of our line is 6 over 5, or 6/5. And there's no simplifying that. It's the same as 1.2, but we don't really care about the decimal. You can leave it as 6/5. Let's look at number 8. So number 8, again, slope is equal to rise over, and I'm going to do all the x stuff in red, run. So our rise is difference in our y values. And remember, our run is difference in x values. So our difference in y values. So let's find our y values. You have x, y, x, y. So our y values are 2 and negative 3. So we're going to subtract them. 2 minus negative 3. Again, be very careful with those negatives, all right? And then our run would be subtracting the x values. So the x values are negative 3 and negative 2. So we're subtracting those. Negative 3 minus negative 2. Again, just be really, really careful with your negatives. There's always going to be a minus sign, but if you have a negative, essentially have another minus sign, right? There's going to be 2 if you're doing a negative number. So now when we simplify this, this essentially is like 2 plus 3 because the minus negative makes kind of a plus. So this ends up being 5 on top. And on the bottom, again, you have a minus negative, so it's kind of like a plus as well. It's negative 3. Think of it like a negative 3. Oops. Negative 3 plus 2, which gives us negative 1. So our slope is 5 divided by negative 1, which does come out to a simple number, just negative 5. So again, you're really just subtracting the y's and you're just subtracting the x's. Just be really careful with your negatives, and you should have the right idea. All right. I'm going to end this video here. It's just been a little bit of time, but if we have time, we'll go back and we'll finish the rest of these notes in another video. All right. I'll see you guys later.